Something is wrong with the moon. Scientists know it. They have known it for decades, and most of them will quietly admit, when pressed, that the moon should not be there, not where it is, not the size it is, not doing what it does. The moon is too big, too perfectly placed, too precisely sized, and too deeply connected to every living thing on this planet to be a coincidence. The more you study it, the more unsettling it becomes, because the numbers don't add up, the position doesn't make sense, and the alternative explanations, the ones that avoid the strangest conclusions, keep failing. This is not a conspiracy theory. This is planetary science, and planetary scientists are genuinely baffled. Here is what we know. The moon is 384,400 kilometers away, and from where you stand on the surface of this planet, the moon appears to be almost exactly the same size as the sun. The sun is 400 times larger than the moon. But the sun is also 400 times farther away. The result is a geometric coincidence so precise, a ratio of 400 to 400, that during a total solar eclipse, the moon covers the sun with perfect exactness, not slightly too small, leaving a ring of fire around the edges, not slightly too large, blocking out a corona of light. Perfectly, exactly, like a lid placed over a jar. The odds of that being random are astronomically small, and it gets stranger. The moon rotates at exactly the right speed to always show Earth the same face, not approximately the right speed. Exactly. In the entire solar system, among hundreds of moons orbiting dozens of planets, this kind of perfect tidal locking to show one face and only one face is common. But the moon's lock is unusually precise, unusually stable, and has been maintained for billions of years. Scientists have an explanation for this. We will get to it. But the explanation raises its own questions, deep ones. And then there is the composition problem. The moon has almost no iron core. Earth's iron core makes up about 32% of Earth's total mass. The moon's core is tiny, maybe 1 to 3% of its mass. If the moon formed from the same cloud of material as Earth, it should have similar proportions. It doesn't. But if the moon came from somewhere else, captured from deep space, wandering into Earth's gravitational field, the chemistry doesn't match either. Moon rocks and Earth rocks have isotopic signatures so similar they might as well be twins. The moon is made of the same stuff as Earth, but it's structured completely differently. There is only one scenario in the history of planetary science that explains all of this at once, and it involves a collision so violent, so total, so catastrophic, that it should have destroyed everything. It didn't. Instead, impossibly, it created the world's most perfect companion. This is the story of how the moon was born, what it did to Earth, what 12 humans found when they walked on it, and what it is about to reveal in the next 10 years that will change everything we think we know about where we came from. Stay with me, because this gets a lot stranger before it gets clear. 4.5 billion years ago, the solar system was trying to kill itself. There was no order yet, no stable orbits, no planets in their current positions, just a vast disk of rock and gas and ice spinning around a new star with thousands of worlds in the process of forming, colliding, merging, fragmenting, growing, in a chaos so violent that if you could stand outside the solar system and watch, it would look like a slow-motion explosion, frozen in time. Earth existed, but not the Earth you know. It was a molten ball of rock, its surface a global ocean of magma thousands of kilometers deep, bombarded constantly by falling debris. No oceans, no atmosphere worth mentioning, no life, just heat and pressure and the constant rain of collisions. And then something came out of the dark. Scientists call it Theia, named for the Greek Titaness, who gave birth to the moon goddess Selene. Theia was a planet, roughly the size of Mars, about half the diameter of Earth, and it had been orbiting the Sun in an unstable path that brought it, over millions of years, on a slow, inevitable collision course with the young Earth. What happened next took about 4 hours. Theia struck the proto-Earth at an oblique angle, not head-on, not a glancing sideswipe, but something in between. The impact released energy equivalent to billions of nuclear weapons detonating simultaneously. In the first seconds, Theia's crust and mantle were vaporized. Earth's outer layers were blasted into space. The two iron cores, Theia's and Earth's, merged in a collision so intense that the rock around them didn't just melt, it became plasma, a state of matter so hot that atoms themselves begin to break apart. A ring of debris, molten rock, vaporized mineral, superheated gas, was thrown into orbit around what remained of Earth, a disk of destruction circling a wounded planet. And then something extraordinary happened. The debris began to pull itself together. Within 100 years, fast by any measure, that disk of wreckage had coalesced into a new world, the Moon, born from catastrophe, built from the remains of two dead planets. Larger than any moon it had any right to be. Here is where the story gets complicated. When scientists tested the moon rocks brought back by Apollo astronauts, they expected to find the chemical fingerprint of Theia, a foreign world distinct from Earth. Instead, they found something that made no sense. The moon rocks were chemically almost identical to Earth rocks, same oxygen isotopes, same mineral signatures, as if the moon hadn't been formed from a collision at all, as if it had simply grown from Earth itself. This set off a scientific crisis that is still not fully resolved. Some researchers propose that Theia and Earth formed from the same region of the early solar system, the same chemical neighborhood, which is why they share a fingerprint. Others propose that the impact was so violent, so total, that the two bodies were completely mixed together before the moon formed, erasing any distinction. Others, and this is where it gets truly unsettling, proposed something else entirely. What if the giant impact happened differently than we think? What if the collision was so energetic that Earth itself was transformed, spun into a donut shape, a rapidly rotating ball of vapor before condensing back into a sphere? In that scenario, the moon wouldn't have formed from a mix of Theia and Earth. It would have formed almost entirely from Earth's own material, which would explain the chemistry perfectly. But it would mean the impact was far, far more violent than any current model suggests. It would mean the early Earth was basically destroyed and rebuilt from its own wreckage. And it would mean the moon is not a companion that joined us from outside. It is a piece of Earth itself, torn away, placed in orbit, watching us from a distance, measured in hundreds of thousands of kilometers. We are looking at a part of ourselves when we look at the moon. That is either poetic, or it is one of the most disturbing facts in planetary science. Possibly both. But here is what is really unsettling. The moon didn't stay where it formed, and the direction it moved from the very beginning was away from us. Something has been pushing the moon away from Earth, slowly and steadily, for 4.5 billion years. And that something is us. Which brings us to what the moon did to this planet, what it is still doing right now, and why, without it, you would not exist. The moon is moving away from you right now, not fast, 3.8 centimeters per year, about the rate your fingernails grow, but it has been moving at that rate for 4.5 billion years. When the moon first formed, It was 15 times closer to Earth than it is today, so close that it filled a massive arc across the ancient sky, so close that its gravitational pull produced tides not of meters, but of kilometers, walls of ocean roaring across the early Earth, driven by a moon hanging enormous and close in the sky. That sounds like a catastrophe. It was, and it is also, almost certainly, the reason you are alive. Here is what scientists believe happened. The early Earth's tidal zones, the shallow coastal areas that were repeatedly flooded and exposed by those massive tides, became the most chemically active environments on the planet's surface. Every few hours, the sea would surge inland, depositing minerals, organic molecules, dissolved gases. Then it would retreat, leaving tidal pools. The pools would concentrate under the sun. The molecules inside would interact. Then the tide would return, flooding the pools, mixing everything again, over and over. For hundreds of millions of years, a giant mixing bowl powered by the gravity of the moon. This repeated wetting and drying, chemists call it wet-dry cycling, is increasingly believed to be the mechanism that produced the first self-replicating molecules, the first RNA, the first hints of genetic code, the chemistry of life itself, bootstrapped by the rhythmic pull of a moon that happened to be exactly the right size, at exactly the right distance, orbiting at exactly the right speed. Remove the moon, and the tides are a fraction of their actual size. The cycling slows. The concentration never reaches the threshold needed. The chemistry stalls. Remove the moon, and life on Earth may never have begun. But the moon does something else, something that most people have never heard of, and that is arguably even more important. It holds Earth still. The Earth is tilted on its axis at 23.5 degrees. This tilt produces the seasons: summer when your hemisphere leans toward the sun, winter when it leans away. The seasons drive climate. Climate drives evolution. Everything about the diversity of life on this planet. Every adaptation to heat and cold, to wet seasons and dry ones, to the rhythms of migration and hibernation, traces back to the tilt. But without the moon, the tilt would not stay at 23.5 degrees. Computer simulations of Earth without a moon show that the axial tilt would wander chaotically, shifting from near zero to as high as 85 degrees over millions of years. And 85 degrees means the poles point almost directly at the sun. For half the year, the equator would be in permanent darkness. For the other half, the poles would receive more sunlight than the tropics do today. The temperature swings would be so extreme, hundreds of degrees between seasonal extremes in some locations, that the oceans would partially boil and freeze in the same year. No complex life could survive that. Not consistently. Not long enough to evolve intelligence. Mars has no large moon. Mars's axial tilt has varied from near zero to 60 degrees over its history. Some researchers believe this is why Mars, which had liquid water, a thicker atmosphere, and possibly even primitive life billions of years ago, became the frozen, irradiated desert it is today. Its axis wobbled, its climate swung, and whatever was beginning to grow, there was erased. Earth has the moon. Earth's axis doesn't wander. Earth's climate is stable enough over geological time to allow the continuous, uninterrupted chain of evolution that produced every species alive today, including you. Now, here is the part of this story that almost nobody talks about. The moon is also doing something to time itself. It is literally changing how fast the Earth spins. And what it has already done, over billions of years, is one of the most quietly staggering facts in all of science. 4 billion years ago, an Earth day was 6 hours long. 6 hours. The planet was spinning 4 times faster than it does now. The moon's tidal friction, the constant drag of those ocean bulges on the rotating Earth, has been slowly breaking our rotation for billions of years. Without that breaking, the weather would be catastrophic. Permanently. Coriolis effects from the faster rotation would generate hurricanes strong enough to scour the surface. Wind speeds that would make anywhere on Earth's surface uninhabitable for anything complex. The moon slowed us down, stretched our days to 24 hours, made the weather survivable, made civilization possible. And now, in the 20th century, a species that owes its entire existence to the moon decided it wanted to go there. What came next was the most dangerous, most expensive, most impossibly ambitious thing our species had ever attempted. And it started not with science. It started with fear. 30,000 years ago, someone was counting the moon. We don't know their name. We don't know what language they spoke. We don't know what they believed, or how they organized their society, or what kept them awake at night. What we know is that they took a small piece of bone and carved 29 notches into it. 29, the exact number of days in a lunar month. They were building a calendar, before writing, before agriculture, before cities or trade routes, or any of the things we call civilization. The most ancient intellectual achievement we have ever found is a human being carefully counting the moon. The Lubombo bone is 35,000 years old. Found in a cave in southern Africa. 29 notches, deliberately, precisely carved. It is sitting in a museum right now. And every time someone looks at it, they are looking at the moment our species realized that the sky was not random, that the universe had patterns, that if you paid attention, you could predict what came next. That insight, that the moon follows rules, is the seed of all science. Every equation ever written, every experiment ever run, every satellite ever launched traces its lineage back to someone sitting in firelight 35,000 years ago, scratching notches into a bone. But here is what haunts me about that bone. This person, this anonymous human, in a cave in southern Africa 35,000 years ago, was doing something that required weeks of careful observation. They had to watch the moon rise night after night, count the days, remember what they saw, and then make a mark. Not because anyone told them to, not because it served an immediate survival purpose, but because something in their mind said, "This matters. Track it. That is not an animal behavior. That is the beginning of science." And it happened because of the moon. Every major civilization that followed built the moon into the architecture of their world. The Babylonians tracked the moon's movements with such precision that by 700 BCE they could predict lunar eclipses years in advance. Not because they understood orbital mechanics, that was still 2,000 years away, but because they had been watching, recording, and counting for so long that the patterns had revealed themselves in the data. Stonehenge, built in stages between 3000 and 1500 BCE on the Salisbury Plain of England. The famous alignment with the summer solstice sunrise gets most of the attention, but researchers have spent decades arguing that the monument's full geometry, including the positions of 56 pits arranged in a perfect circle, encode the 18.6-year nodal cycle of the moon, the slow wobble in the moon's orbital path that produces the most extreme tides, the most dramatic eclipses. If true, Stonehenge is not just a solar calendar. It is a computer for predicting the most powerful moments of lunar influence, built from 25-ton stones. By people using antler picks to dig the chalk, they moved those stones from Wales, 225 kilometers, without wheels, without metal tools, without draft animals strong enough to pull such weight, and they placed them with an astronomical precision that modern engineers struggle to replicate. Why? Why would people in the Stone Age commit that kind of labor to a lunar calendar? Because the moon controlled everything. The tides that determined when to fish, the light that determined when to travel, the cycles that governed agriculture, childbirth, hunting, warfare. The moon was not decoration. It was infrastructure. The most important technology in the ancient world was understanding the sky. And then, in 1901, divers working off the Greek island of Antikythera pulled something from a 2,000-year-old shipwreck that rewrote history, a corroded bronze lump. It sat in a museum for 50 years, largely ignored. When researchers finally X-rayed it in the 1970s, they found something inside that should not have been possible. Interlocking bronze gears, more than 30 of them, some as thin as 2 millimeters, that calculated the movements of the sun and moon, predicted eclipses, tracked the 4-year Olympic cycle, and displayed the positions of the planets. Built in ancient Greece around 100 BCE. It is the world's oldest known analog computer, and its most complex function, the function that required the most sophisticated engineering, was calculating the moon. The mechanism accounts for the fact that the moon's orbit is not a perfect circle. It speeds up when close to Earth, slows down when far away. Accounting for that variation required a pin-and-slot mechanism that is, by any measure, a feat of precision engineering. An engineering tradition that was lost, completely, when the classical world collapsed. How many of these devices existed? How much knowledge was destroyed? We don't know. We will never know. What we know is this: for as long as there have been human minds capable of complex thought, those minds have been locked onto the moon, building machines to model it, encoding its cycles into stone monuments, carving its rhythms into bone. The moon has always been calling to us. We just needed to build the right machine to finally answer. On October 4th, 1957, the Soviet Union put a metal ball into space. And in one terrible moment, the United States realized it was losing a war no one had officially declared. Sputnik weighed 83 kilograms. It had no weapons, no cameras, no scientific instruments of any significance. It just beeped, a simple radio pulse that amateur radio operators around the world could pick up on their home equipment. But what that beep meant was this: we got here first, and if we can put this in orbit, we can put a nuclear warhead in orbit, above your cities, beyond your reach. The panic in Washington was genuine. The CIA called it a catastrophic intelligence failure. Congressional hearings were held, and the word Sputnik entered the English language as a synonym for unexpected, humiliating defeat. Then it got worse. Less than a month later, the Soviets launched Sputnik 2. This one carried a passenger, a dog named Laika. She was the first living creature to orbit Earth. She died in orbit. They didn't have the technology to bring her back, but the point had been made. Then April 12, 1961, the date that changed everything. Yuri Gagarin, a 27-year-old Soviet Air Force pilot, orbited Earth in 108 minutes and returned safely. First human being in space. First to see the curve of the Earth from above. First to look out a porthole and see the universe without the filter of an atmosphere. 3 weeks later, Alan Shepard became the first American in space, a 15-minute suborbital arc. He went up and came back down. He didn't orbit, he hopped. The United States was losing. Visibly, publicly, in front of the entire world. And that is when John F. Kennedy did something that no president had done before, and possibly none has done since. He made a promise the country had absolutely no ability to keep. On May 25, 1961, Kennedy stood before Congress and said, "I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to Earth." The total American spaceflight experience at that moment: 15 minutes, one man, one suborbital hop. The technology required to go to the moon did not exist. The rockets were too small. The computers were too primitive. The spacesuits didn't work in vacuum. The guidance systems couldn't hit a target 250,000 miles away. The lunar landing vehicle was a sketch on a napkin. Kennedy wasn't making a plan. He was making a bet that the world's richest nation could throw enough money, enough engineers, enough ambition at a problem to solve it in 8 years. NASA's budget quadrupled, then quadrupled again. At its peak, the Apollo program consumed 4.4% of the entire United States federal budget. 400,000 people worked on it. Not just astronauts, mathematicians, welders, seamstresses who hand-stitched the spacesuits. Women working with slide rules in buildings called computing rooms, doing the orbital calculations by hand. And through it all, the Soviets kept winning. Luna 9 landed on the moon's surface in 1966. Luna 10 became the first spacecraft to orbit the moon. The USSR had a parallel crewed program that was a genuine threat right up until its own internal disasters destroyed it. The race was real. The outcome was not certain. And 3 American astronauts, Gus Grissom, Ed White, and Roger Chaffee, died in a launchpad fire in January 1967, adding grief and doubt to a program already under enormous pressure. But the program continued, because stopping meant admitting defeat. And defeat in 1967 was not something anyone in Washington could contemplate. On July 16, 1969, the Saturn V rocket, 111 meters tall, generating 7.6 million pounds of thrust, the most powerful machine human beings had ever built, lifted Apollo 11 off the pad. Neil Armstrong, Buzz Aldrin, Michael Collins, 4 days to get there. And when they arrived, when the Eagle separated from the command module and began its descent, there was a moment when everything nearly ended before it began. A moment that almost killed the mission, and almost killed them. Nobody who wasn't in mission control that day knew how close it really was. They were 30,000 feet above the moon when the alarm went off. 12:02, a program alarm. In mission control, a 26-year-old flight controller named Steve Bales had approximately 3 seconds to decide whether to abort the landing or continue. He had never seen this alarm in a real mission. He was not certain he believed, that it meant the computer was overloaded, but still functional. He said, "Go." The Eagle kept descending, and then Neil Armstrong looked out the window and saw where they were headed. The landing computer was targeting a crater 180 meters across, rimmed with boulders the size of cars. Landing there meant certain destruction. Armstrong took manual control. He flew the Eagle horizontally across the surface, searching for flat ground, burning fuel that was measured not in minutes, but in seconds. With 30 seconds of fuel remaining, the Eagle set down. Armstrong's heart rate at touchdown was 150 beats per minute. He had been a test pilot for 20 years. He had ejected from a malfunctioning aircraft. He had flown experimental planes to the edge of the atmosphere. His pulse at touchdown was 150. That tells you something about what those final minutes were like. Houston, Tranquility Base here. The Eagle has landed. In mission control, grown men, engineers who had spent years conditioning themselves to maintain professional detachment, wept openly at their consoles. 6 hours later, Armstrong descended the ladder. What he saw was a world unlike anything in human experience. The surface was a fine, grey powder, like talcum dust, produced by billions of years of micrometeorite impacts grinding the surface rock. It had never been touched. Not by wind, not by water, not by anything. The footprints Armstrong made in that dust were the first marks ever left by life on the surface of another world. The sky above him was black, not the soft blue-black of a clear night on Earth. Absolute black, the black of space, with no atmosphere to scatter light and soften the darkness. In that black sky, the sun blazed with an intensity that would have been blinding without the gold visor. Shadows on the moon have no soft edges. Every shadow is a sharp, absolute line between intense light and complete darkness. And the silence. No atmosphere means no medium for sound to travel. The only sounds Armstrong could hear were the mechanical hum of his life support systems, the crackle of radio, the sound of his own breathing. The moon is the quietest place any human being has ever stood. Buzz Aldrin climbed down 20 minutes later. He looked out at the landscape and said 3 words that have become among the most famous in the history of exploration: magnificent desolation. They had 2.5 hours on the surface. They collected samples, they deployed instruments, they planted an American flag with a horizontal rod sewn into the top so it would appear to fly in a place where there is no wind to move it. And before they left, Armstrong placed a small silicon disc on the lunar surface. Engraved on it, messages from the leaders of 73 nations, and the words, "We came in peace for all mankind." 8 hours after landing, they left. The ascent engine fired. The Eagle rose from the surface, leaving behind the lower half of the lander, the flag, the instruments, and the footprints. Those footprints are still there, perfectly preserved. The moon has no weather, no erosion, no wind, nothing to disturb the surface. Every footprint, every rover track from every Apollo mission, all of it sitting exactly where it was placed, in the grey dust, waiting. 12 humans walked on the moon between 1969 and 1972. The last was Eugene Cernan, Apollo 17, December 14, 1972. As he climbed the ladder for the last time, he said, "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." Then he flew home, and for 50 years, no human being went back. But what those 12 men brought back, 382 kilograms of rock, contained secrets that nobody expected, including one secret that overturned everything scientists thought they knew about the moon. A secret that was hiding in plain sight, and we almost missed it entirely. The most important discovery about the moon was not made on the moon. It was made in 2009 by a spacecraft that NASA deliberately crashed into it. LCROSS, the Lunar Crater Observation and Sensing Satellite, was aimed at a permanently shadowed crater near the moon's south pole, a place where sunlight never reaches, where the temperature hovers around -250 degrees Celsius. The spacecraft hit the surface at 9,000 kilometers per hour and threw up a plume of material 12 kilometers high. Scientists watched that plume with every instrument they had, and what they found shattered a belief that had been held since the Apollo astronauts first returned with their dry, dusty samples, water, ice, hundreds of millions of tons of it. For 40 years, scientists had assumed the moon was completely dry, bone dry. The giant impact that formed it would have vaporized any water. The moon was a dead, dry rock. That was settled science. It wasn't settled. We were looking in the wrong places. Inside those permanently shadowed polar craters, ice deposited over billions of years of comet impacts has been perfectly preserved, a natural freezer sealed shut for 4 billion years, colder than the surface of Pluto, colder than many places in deep space. The water has been sitting there, waiting, since before the first single-celled organism existed on Earth. And here is why that changes everything. Water can be split into hydrogen and oxygen, the two components of rocket fuel, using electricity. Solar panels on the moon can generate that electricity, which means the moon is not just a destination. It is a gas station, a refueling depot on the edge of Earth's gravity well. Escaping the moon takes a fraction of the energy it takes to escape Earth. If you can manufacture fuel on the moon from lunar ice, you can refuel spacecraft there for a tiny fraction of what it costs to supply them from Earth. The moon becomes a launch pad for the rest of the solar system. Mars, the asteroid belt, the outer planets. All of it becomes vastly more accessible if humanity has a permanent, fueled base on the moon. The cost of deep space exploration drops by orders of magnitude. But water ice is not all the moon is hiding. The moon rings like a bell when struck by a meteorite. Not briefly, for hours, sometimes for days. The Apollo seismometers detected this. The vibrations travel through the moon differently than they should if it were solid rock all the way through. The data suggests a hollow or partially hollow structure in the upper mantle, not a vast empty space, but a complex layered interior that current models don't fully capture. And then there are the mascons, mass concentrations, regions where the moon's gravity is stronger than the rock density should allow. We have a partial explanation, but only partial. And then, in 2017, Japanese lunar orbiters found something that made planetary scientists stop and look at each other. A pit, a hole in the surface near the Marius Hills, leading down into a tunnel. A lava tube, a natural underground channel formed billions of years ago, when lava flowed beneath a hardened surface crust. On Earth, lava tubes are a few meters wide. On the moon, where gravity is 1/6 as strong, the same volcanic process can produce tubes tens of meters wide, or, in this case, possibly hundreds of meters wide, kilometers long. We aimed radar at it. The radar signal went in, and the shape of the echo that came back suggested an open space large enough to place an entire city inside, protected from radiation, protected from micrometeorite impacts, protected from the extreme temperature swings of the lunar surface, which vary by 280 degrees between lunar day and night. A ready-made shelter, built by geology billions of years before anyone needed it. We have never sent a probe inside. We have never explored it. We don't know how deep it goes, or how far it extends, or what the floor looks like, or whether there is ice down there in the permanent dark. We are going to find out. And what we find may determine whether humanity has a future beyond this planet. Because here is the thing nobody says out loud. Earth is not forever. In roughly 600 million years, the moon will be too far away to produce total solar eclipses. Not because of a catastrophe, not because anything unusual will happen, just because the moon is moving away from Earth at 3.8 centimeters per year. And 600 million years of that movement adds up. We live, right now, in this specific window of geological time, in the only era when total solar eclipses are possible on Earth. The first 4 billion years, the moon was too close and too large. In another 600 million years, it will be too far and too small. We are in the exact precise moment when the geometry works. Think about what that means. Every total solar eclipse in human history, every one witnessed by ancient astronomers who used the moment to calculate the moon's distance, by scientists who used it to confirm Einstein's theory of general relativity, by every person who has ever stood in the path of totality and watched the sky go dark in the middle of the day. Every single one of those moments only exists because we happen to be alive in this specific, brief window of the Earth-Moon system's history. We got lucky. Cosmically, almost impossibly lucky. And what we did with that luck is now approaching its next chapter. The Artemis program, NASA's return to the Moon, is not Apollo 2. It is not a flags and footprints mission. It is the beginning of permanent human habitation of another world. A lunar gateway station is being assembled in orbit. Commercial landers from multiple companies are already flying. China has landed 3 missions, returned fresh samples, and announced plans for a crewed landing before 2030. More spacecraft are headed to the Moon right now than at any time since the Apollo era. Everyone is going back, and this time, no one is planning to leave, because the Moon is not just the Moon anymore. It is the first domino, the first step in a chain that leads, if we don't destroy ourselves first, to the rest of the solar system. The lava tubes that could shelter human cities, the water ice that becomes rocket fuel, the helium-3 baked into the lunar surface by billions of years of solar wind, a fuel source for the fusion reactors that could power our civilization for thousands of years. And beyond the Moon, Mars, the asteroid belt, which contains enough mineral resources to make every person alive a billionaire thousands of times over. The outer planets and their moons, some of which, like Europa and Enceladus, have liquid oceans beneath their ice that may harbor life right now. None of it is accessible without the Moon as a way station. None of it is possible without starting there. But I want to end not with economics or exploration timelines. I want to end with something that happened on Christmas Eve, 1968. Apollo 8, the first crewed mission to orbit the Moon, was making its 4th orbit when astronaut Bill Anders looked out the window and saw something that had never been seen before. Earthrise. The Earth, rising above the lunar horizon, blue and white and impossibly vivid against the absolute black of space. A marble of color in an ocean of dark. The only colored thing in a universe of black and gray and the harsh white of the sun. Anders grabbed his camera and shot the photograph that became, perhaps, the most important photograph ever taken. Earthrise, the image that launched the modern environmental movement. The image that made people, for the first time, see their home as a single, finite, fragile thing. Not divided into countries and continents, but whole. One world, one atmosphere, one ocean. The Moon showed us what Earth actually is. You have to leave home to see it clearly. Neil Armstrong's footprints are still in the Sea of Tranquility, exactly as he left them. Preserved in the grey dust of a world with no weather, no wind, no rain, no erosion. They will still be there in 1 million years, in 10 million years, when the continents have moved and the oceans have shifted, and whatever comes after humanity looks up at the same moon we see tonight, those footprints will still be there. That is a strange thing to sit with. The most fragile, most human act, a person stepping carefully across unfamiliar ground, preserved forever in the most permanent medium imaginable. The Moon is 4.5 billion years old. It watched the first cells divide. It watched the first fish crawl onto land. It watched the first fires, the first cities, the first words written. It watched every empire rise and fall. It will be there long after we are gone. And in all that time, in all 4.5 billion years, there was one moment that was genuinely new. One moment that had never happened before and could never unhappen. July 20th, 1969. a living creature from the third planet, crawled out of its machine, stepped onto the moon, and looked back, and saw home. A blue marble, impossibly bright, impossibly small, hanging in the black sky above the grey dust. No borders visible, no boundaries, just a single, luminous world, breathing, living, fragile, suspended in nothing. Go outside tonight. Look up. You are looking at the oldest friend this planet has ever had. The thing that gave us our tides and our seasons and our stable climate and our long, slow days. The thing that may have started life here. The thing that held our axis still while evolution did its work across billions of years. The mystery of the moon is not that it exists. The mystery is that it exists exactly as it does, the right size, the right distance, the right composition, doing exactly the right things at exactly the right times. Maybe that's coincidence, maybe it isn't. Either answer is terrifying, and either answer is beautiful. Look up.